Say again? 14. And then this is going to be 28 and 27. I almost had equal representation there. 55, all right. So you can make sure it adds up the same both ways, just to make sure you got all the numbers right. Don't, by the way, if you happen to put a 20 here by accident, your brain went a little south, and then it messes up your numbers, I'm just going to take points off once, and then as long as you actually did everything else right, you'll be okay. That would so suck to have step 1, it messes up steps 2 through 80. It's like, well... So I've had teachers that if you miss the first one, you just miss the whole test, and you get a 0. It's like, well, I love you, you're awesome. There's probably somebody who was in one accident. Yeah, I didn't say anything about them having to be over 30. Just what probably somebody's has one accident would be 21, had the one accident out of 55 total possibilities I could have picked. I like it. Say again? Oh, okay.
38.1%. 38%.
It's about 38%, okay.
Why is it 21? Didn't you say pick one out of one person? Or what?
Yeah, pick one person. So I just pick one person. That's all I pick. I really want this to make sense, though. If I said pick one person, the top isn't always going to be 1. It should be much more likely to pick somebody who's under 30 than it is to pick somebody who's had 2 accidents. You agree with me? In fact, it should be twice as likely to pick this as this. So it's all based on the amounts that match what you're looking for. I'm looking for somebody who had 1 accident. Well, how many match that? 21.
Okay.
21 instances that match what I want out of 55 things that I could pick. So think about it this way. 21 times out of 55, I would pick somebody who had 1 accident, because that's how many there are out of 55. Okay. Maybe. So what about over 30?
27.
Yeah, there's 27 people over 30. So for this problem, the bottom is always going to be 55, unless what? Unless I have something I've given you. Unless I'm giving you some information. What's up, buddy?
I'm just looking at that.
Oh, okay, I'm sorry. So then what's this come out to be?
49%.
49%. Now let's see, under 30 and no accidents.
7.
Yeah, only 7 people out of
55.
55, because I didn't give you any information. It could still be any of the 55 people. But there's only 7 that do both this and this.
13%.
Round it up to 13%.
Whoop. So here's our first given. So the first thing I do when I see a given is I figure out what the bottom is going to be. What's the bottom going to be based on?
The total. 28.
Total people that did what?
Under 30.
Good, under 30. Given that they're under 30. People read this wrong. I'm not given that they have 2 accidents. The probability they have 2 accidents. Given this. So how many people under 30?
28.
28.
So would it be
12.
So now your whole universe is that. Because you know it ain't none of them, so throw them out. That was them getting thrown. Out of those people, how many had 2 accidents?
12.
12. I like it.
Which is 43%.
I like this system.
So here's the... Yeah, I like that you said that, because it...
It's about to get not good, isn't it?
Well, no, there's actually not much more we're going to do with this in chapter 7, to be honest. There's a few things that I got to go back and be specific about, but we basically just did most of every section in chapter 7, just now. There's a section specifically on and or. There's a section specifically about given. There's a section specifically about how probabilities work, period. Right? So they just really cut it up. So let's look at that. These are the last thing we're going to do today. Right? Hold on. No, let's out.
I'm so scared.
No, let's out stupid early, so just be ready. Alright. You know, like, dude, I ain't got to get ready for that. You just, whenever you want to. look at that last thing we did. This probably 2 given. I want to develop the formula for this. Now listen, there is a formula for given. There is a formula for given. Do we know what it is yet?
No.
Did we answer that question anyway? Yes. So anytime you have stuff you can count, I'm not going to use a formula. I'm just going to count it and put it together. We just did it without the formula. When people try to force the formula in, they don't use it correctly because it's harder to look at it that way. So why is there a formula? Well, for situations that I have nothing to count. I just have probability of A is 0.7, and the probability of B is 0.4, and the probability of A and B, and they just give me stuff. So I got to use the formula to figure stuff out. So help me out here. What was the bottom related to?
Total of everything that could be.
It was related to the given. Okay. And what was the top? Now listen. The top isn't this, right? It isn't just the probability of 2 accidents. What did we put on the top? We put 12, but weren't there 14 accidents? 14 2 accident situations, right?
But the other 2 were over.
So why did we just put a 12 there?
Because the other 2
Because I know that they're under 30. The only way they could be 2 is if they're both at the same time. So the top of this was actually 2 and under 30. So here's the formula in general. This is going to be on your next iteration of your formula sheet. The probability of A given B. So these capital letters, I'm going to give us the general formula for this. These capital letters are like probability variables. A could stand for had 2 accidents. B could stand for where it was under 30 years old. They could stand for whatever, rolled an odd number on a die, or found a 5-legged dog, whatever. Right? So, yeah.
What does the given act as, like a multiplication?
It's just extra information. So this is remarkably important. You have no idea. And you're like, yeah, you're right. I have no idea. This is how I begin to explore how does this affect this. Now, if I calculate this and it's the same as what this was, then I call that they're independent. So if this came out to be equal to this, don't write this down. We're going to talk more about this later. If that became this still, so B happened and A didn't give a shit. They are independent events. They don't affect each other then, right? Or if it does affect each other, how much do they affect each other? So for example, the probability that you're going to develop cancer given that you have a certain hereditary marker or a certain gene, right? Versus probably going to get cancer. Well, if it goes way up versus that, then you're like, oh, we got to look for that gene, and then we can warn people, you got to be careful, don't eat this, you got to be careful, you're more predisposed to get cancer. This sounded all familiar. This has happened several times.
Yep.
This is a very, very basic tool to be able to start to analyze that possibility. Some of you guys might realize this may be just a little more complicated than this, but not at the very beginning, to be honest. Okay, so here's the formula. So on the bottom is going to go the given thing. Whatever was given. And on the top is going to go all the A's that are also B's. Right? We know B happens, so what's the only way A could also happen? If it's A and B. Let me give you a visual. So here's A, here's B. If I tell you that B happened, given B happened, what's the only way that A can happen at the same time is if it's in
overlaps
here. And what is that area? That is what? That is A
Plus.
and, not plus.
and
A and B. That's why this number was a 12 and not a 14. Because the only way it could be 2 accidents is if it was somebody under 30 with 2 accidents, because I know they're freaking under 30. Okay, good. One thing is another formula and shove stuff into the formula. Another thing is, do you understand why the formula makes sense? In a way, it almost has to, because that's what we did without even knowing this shit. We just did it, because it made sense.
So right there is the formula.
That is the formula for given. I like it. So before I let you go, We're going to develop formulas for or and tomorrow. But today, just to show you an example where you have to use a formula. If I told you that we know the probability of B is 0.8, what's up?
I was trying to figure out what that is on that side of the parentheses. Is that an EX?
Yes. And the probability of, let's say, A given B is 0.25. Don't say anything out loud. Take a second. Can you figure out what the probability of A and B is?
So that's the question.
Yep, that's the question. And these are the things I told you. That should be enough to figure this out. This is my way of sneakily getting the equation for and. Now I understand this is very different look from algebraic equations, right? Okay. But now, in place of this whole thing, what am I going to put here? On this side, what am I going to replace this whole thing with? What do I know this is? 0.25.
Right.
So this whole thing is like x. The probability of something happening, I can put a number in its place. Don't try to plug stuff in here that doesn't make any sense. This whole thing, the probability of this is 0.25, so I can just put a 0.25 here. What else do I know?
And then you know B is 0.8.
I know probability of B is 0.8. And I'm asked to figure out the probability of A and B. So, of course, how do you do that? It's very nice, simple algebra, hopefully.
25 times 0.
Yeah, multiply by 0.8, right? X over 0.8 equals something. You multiply by 0.8 to get x by itself. It's the same exact idea. So if I multiply by 0.8, what's 1/4 of 0.8? Yeah, 0.2. So multiply by 0.8 so it cancels. So now you know that that equals this times this. So the formula for and, we actually just figured it out. How do we figure out the and? We multiply this up, right? So the probability of A and B equals probability of B times probability of A given B.
Holy moly.
Okay, I appreciate that. Kind of sleepy reaction, that was good. Alright, we did a lot today, so we're going to continue to unpack it. But if you do section 7.4, that's just basic probability. 7.6 and 7.7 get into and, or, and given. So we got a few more specifics to do. But I feel okay about giving us an early day. When I say us, I really mean us.
You landed out soon.
What's up?
You landed out this early?
Yeah.